Hello guys, welcome back to our channel, and in this video, we're gonna show you of how we did the application of trigonometry. But first, what is the application of trigonometry? The application of trigonometry helps us to determine the measure of the height, distance, and angle in a structure. And in this video, we're gonna show you how.
How the data was measured. We employ a two-step procedure to determine the measurements. First, we need to find out how far is it for a person to see the top of the structure. To do this, we measure the horizontal distance by starting to the base of the post to where the person will see the top of the structure. Using a tape measure, we found out that the distance is 6 meters or 20 feet. Next, we need to measure the angle of elevation. This is the angle between the ground and the line of sight to the top of the structure. To adjust this, we use an app called Clinometer plus Bubble Level. As you can see, the person is standing on a 20 feet horizontal distance and looks up at the top of the post together with his phone and the application. And it shows that the app measures the angle of elevation in 63 degrees.
To determine the parts of the triangle and application of trigonometry, first we draw the triangle. Now, think of this as the building and then this is Edric. The angle of depression measured by the app is 63 degrees, so we're going to put that here inside the triangle. And the distance of Edric from the building is measured as 20 meters. And also, this is a right triangle, so we're already given 90 degrees. Then we write our given. Now to solve for it, first we're going to use the sum of all angles to solve for A, and also to have a pair here. Now we all know that sum of all angles in a triangle is angle A plus angle B plus angle C is equals to 180. Next, we're going to use law of sines to get angle B and angle C. For law of sines, we have A over sine A is equals to B over sine B is equals to C over sine C. After getting all the answers, we're going to label our triangle with it, and that's it. We have already determined the parts of the triangle using sum of all angles and law of sines.
In order to solve for the trigonometric functions, we first need to do the application of trigonometry. Now, 20m goes over here at the adjacent side, 90 because we're using the right triangle, and 63 degrees because that is the angle we are looking from the lamppost from. So, we must use the sum of all angles to find the other angle. So, 180 minus 90 minus 63 is equal to 27 degrees. After that, this 27 degrees would be put right over here, and this would be our sine A. Now, what is sine A? Well, it comes from the law of sines. The law of sines is A, sine A is equivalent to B, sine B is equivalent to C, sine C. Now, since this is the only law of sines that is complete, we'll be using this to solve for the others. Now, A is 20, since they are at the opposite sides. Since they are the opposite sides and they are directly at each other, 20 over sine A, which is 27 degrees, equals B sine 63. Now, we'll be multiplying both sides by sine 63 in order to cancel the sine 63 squared over here. So sine 63 cancel. So it would be left with sine 63 over 20 sine 27 degrees. After that, divide both of these, which will end up with sine 63 is equivalent to, multiplied actually, multiplied by 44.0537852.9. Now you multiply these two together, which would end up with B equals 39252.
So after Anika finally solved all of the sides, the opposite, the hypotenuse, and the adjacent, we will now start using the Sofatala to solve for the trigonometric function. First, we'll do our sine. We'll do sine theta is equals to 34.2522, and the hypotenuse will be 44.0538. And our cosine next, cos theta is equals to adjacent over hypotenuse. So our adjacent, that will be the given quantity, and our hypotenuse is earlier 44.0538. Next, our tangent, TOA. So that will be tangent tan theta will be opposite over adjacent, and that is 34.2522 over adjacent, that is given 20, and that's it. That will be our sine, cosine, and tangent. But that's not all, because we will now start finding the cosecant, secant, and then the cotangent. And the only thing that we will do is just flip all of this together. So sine, that is opposite over hypotenuse, will be now hypotenuse over opposite, just like that. And let's go. So I'm back, and now we will solve for the cosecant, secant, and cotangent. So for our cosecant, yes, you see, will be hypotenuse, so 44.0. No. That will be, sorry about that. Will be the opposite. So 44.0538. 34.25 20. There. Next, our second. Our cosine is adjacent over hypotenuse. Now this time it will be hypotenuse over adjacent. So that will be 44.0538. And our adjacent. And now our cotangent. Our tangent is opposite over adjacent, so our cotangent will be adjacent over opposite. And what is it for our trigonometric function?
If you want more videos like this, please like, share, comment your thoughts, and click subscribe for more videos. Please don't forget to click the notification bell too. Thank you!